Welcome everyone to today's webinar. We're thrilled to have you here with us. Our session will be led by Luc Esmerit, a partner in AlixPartners Aerospace and Defense practice, who will be moderating a panel discussion with 3 industry experts on developing proven capabilities to help companies regain control of their supply chains. As a reminder, everyone is joining on mute, but we encourage you to drop your questions in the Q&A section at any time. We will aim to address as many as possible in the last 10 to 15 minutes, and for any we don't get to, we will follow up afterwards. This webinar will also be recorded. Let's get started.
Well, thanks for the introduction, and it's great to see so many of you today. Joining me are my colleagues James Hayden, Rob Surf, and Venki Ramesh. And together we are going to dive into the complex world of supply chain management in aerospace and defense. Our industry has faced many challenges, the 737 MAX grounding, COVID-19, labor shortage, just to name a few. And with production ramp up, supply chain teams are under tremendous pressure, often finding themselves trapped into crisis management. The consequences are far-reaching, and we are all aware about that. Delays in delivery, inventory piles up, shrinking margin, all of this directly affecting competitiveness and capacity to secure new contracts. So in this webinar, we're going to explore how supply chain team can take back control of the situation and adopt a more proactive approach by implementing 3 key enablers. The first one is what we call the supply chain watchtower, really to enhance visibility, quantify risk, and make proactive decisions. And the second one is the Span Cube, well-designed, driven by AI for real-time updates to optimize sourcing strategy. And the last one, last topic we're going to talk about is rapid shoot cost model to identify overpriced supplier. So with that said, I'd like to move to the first one and start talking about the supply chain watchtower. Something we I've also heard about called supply chain transparency. And it's a concept that was virtually unknown 10 to 15 years ago, but is now very essential for top performing supply chain organizations. So to discuss this, I'd like to invite James. James, thank you for joining us. Could you begin by explaining why so many supply chain teams struggle today, especially in our industry, aerospace and defense?
Absolutely, Luke, and it's a pleasure to be with everyone here today. I fully agree with your point about supply chain teams constantly firefighting, dealing with issues as they arise, and really having little room for proactive planning and strategy. And I think this stems from really a number of factors. Firstly, undoubtedly, the industry has seen a rise in the number of underperforming or financially distressed suppliers. And this has been compounded by shortages in raw material, geopolitical factors, and just some of the general industry dynamics. And this has placed additional strain on already stretched resources, and in many cases has diverted that attention from the proactive management where some of those suppliers may already be trending towards a distressed situation. Secondly, I think the data landscape in many organizations also makes it difficult to get that comprehensive view of the supply chain, especially in some of those multi-division aerospace and defense companies which have a range of legacy ERPs. And what that means is teams tend to view suppliers through more of a functional lens as opposed to assessing them holistically. And then lastly, I think there's the piece around accountability between the different teams. So program management, supply chain, and engineering. When some of these problems arise, it can often be unclear who's responsible for resolving them, and that can lead to delays and inefficiencies.
Yeah, I think that's a pretty good summary of the situation and what we have observed. And I would add that, I mean, being stuck in high-pressure reactive environments also impact morals and lead to higher turnover, skill loss, which is making it even more challenging to maintain high performance in supply chain organizations. Now, could you explain how the supply chain watchtower is actually addressing some of these pain points?
Yeah, of course. So let's look at a recent situation with a multi-billion-dollar aerospace company that faced severe production delays due to some of the factors that we've talked about today. And really, they lacked visibility into the supplier base and therefore struggled to identify and pinpoint the root causes of some of these challenges the suppliers were facing. So to address this, we developed and customized the supply chain watchtower for them, which really gave them that constant monitoring across the entire supply chain. And the system offered them those real-time insights across all different aspects of the supplier relationship, including quality, part shortages, financial health, all in one place. So let me show you how it works. We'll now move on to the demonstration of the supply-based recovery cockpit. Now, the version I'm going to take you through today is equivalent to what we would usually build in our 8 to 12 week long engagements using off-the-shelf software such as Power BI or Tableau. Now, this version of the tool is perfect for when it's critical to get to that insight view on your supply base as soon as possible to really start mitigating that risk and driving actions and decisions within your team. Now, typically, these tools will continue to develop over time, and some clients will choose to migrate them into more advanced software packages. So we'll run through a few of the key elements within the tool to give you a flavor of some of the capabilities we typically develop. So this is the supplier risk screen and lots of different analytic capabilities, but today we'll take you through the short-term supplier assessment. So what you see here is a typical landing page that you would want to view on a daily or weekly basis, depending on what your usual cadence looks like. Now, what you see here is your suppliers ranked highest to lowest in terms of risk score, and you can see that in the red column. The higher the number, the higher the risk. And then what you can see going across each of the columns are the different scoring dimensions for how we assess the suppliers. So in this particular example, we looked at the suppliers over part shortages, so delivery, financial risk, capacity, quality, transfer of work, and triggers. Now, each of these different dimensions has its own algorithm for how we assess the suppliers using a combination of internal and external data. And we'll work with your teams to make sure we're capturing the right methodology for assessing the suppliers across each of those different elements. Those scores then roll up into an overall risk score, and that's that short-term risk score that you can see here. Now, I know many of you on the call will typically manage your supply base more through a program lens as opposed to just looking at a supply list like this. So we typically develop a similar screen from a program lens, so you can filter between your different programs and see the risk on each of the programs that you have in there and see the suppliers that make up that program and what their specific risk score to that particular program is. One thing I would quickly call out is that the information on these pages is actually updated on a daily basis multiple times. So every time that you log on to the tool, what you see is the latest and greatest. So it really is a great way to collate all of that information across your organization into one place, so you're really viewing those suppliers holistically. Another feature that we typically develop is executive level reports. So here's an example of one such one. And what you can see here is a few different elements. So top left, you can see how your supplier base is broken out into different categories. So you can see suppliers that are on a watch list. You can see how many that you've got planning to exit, or how many you actually have a team out supporting from a recovery perspective. Other visualizations here, you can see how that score progresses over time. And then again, you can see that risk score by program. So you can really get a good idea on where you need to focus your resources and your attention to manage your organization's risk exposure. So the next thing that you're going to want to do after you've viewed the portfolio level risk is really start to drill down into some of these top suppliers and understand what's causing some of the scores that we see here. And for that, we have the company dashboard. So if you click on that button, it's going to open up a landing page such as this. Now, what you can see on this particular example is a few different elements. So top right, you can see the different scoring dimensions for how we assess the company. So you can see the delivery, finance, quality, again, as we saw on that original page. And here you have the double click for ability, so you can really start to drill into that data. So if you're interested in part shortages, you can see on this particular supplier how those shortages have trended over time and really start to understand some of that data in more detail. You can do similar things across the financials, quality, capacity. So really you can start to build out those different relationships and diagnose why this supplier might be having some challenges. Some other elements that it has is obviously the spend, bottom left, how that risk is developing over time. So is it getting better? Is it upticking? And actually one that you might want to keep an eye on. Another element that we have is the company log. And really this is incredibly helpful for when you go out to meet the company or there is an event that you want to record. So for example, imagine you went to go meet the CEO and you were discussing how they plan to build up their capacity, or you wanted to discuss some of the refinancing risk that you see through the financial element. What you can do here is log your particular comments on that supplier, and that's going to feed into this bottom right-hand page here. And we find that this proves to be really useful for building up an overall picture of the supplier, being able to combine some of that data elements, but also some of those softer, more conversational insights. This can prove key when you want to take decisions around resourcing or potentially exiting, or to even maybe giving the company some more business. So having that evidence base is really critical. So once you've used this page to start to diagnose what is causing that risk at the supplier, the next thing that you're going to want to do is start to drive action to manage it. And that's where the action log comes in. So if you navigate to this, we'll just open up this screen here. It's going to open a page such as this. Now, what you can see here is all of the actions that have been allocated to your team to help manage that supplier risk. And they're shown in 3 different buckets. Your overdue actions. So these are the things which should have been complete, which haven't been complete. Your upcoming actions, and then your complete actions. Now, we find this is a really powerful tool for being able to take some of those insights that you see on the company page and then really sharing those insights with your team and then getting them to investigate, getting them to come up with plans to mitigate and manage them and make sure those happen at pace and on a timely basis. So straight away, you can log on to this and see who hasn't met their deadlines, and then you can follow up and make sure what needs to happen is happening as soon as possible. Again, you can add new actions. So here you have the action page. You can specify which vendor, you can specify the type of action, what needs to happen, who needs to do it, when they need to do it by. And what this is going to do is it's going to send a email notification to the assignee, and it's going to tell them what they need to do, and then they can log into the tool and give updates on a regular basis for how they're doing against their deadlines, and then mark it as complete once that's done. So this is particularly useful for being able to manage your team over time, moving away from PowerPoints, where sometimes you move from week to week and things get lost in the decks gone by. This is a really easy way to track things and make sure nothing gets lost and your team feel accountable for delivering what they need to help manage your risk. So really that's a whistle-stop tour of our supply base recovery cockpit. As I mentioned at the very start, we like to make them customizable for the different clients that we work. So what you've seen today is just a flavor of some of the capabilities we like to deploy, but really we'll make it bespoke, working with you and your team to make sure we are helping to identify and then manage the supply chain risk within your organization most effectively.
Thanks for the demo, James. I know for a fact that this is very powerful, and especially to coordinate multifunctional initiatives. And I've heard the CEO of this company for which you have developed this solution being very complimentary and even calling that as a game changer for his organization. So question about the timeline. I believe you mentioned 8 to 12 weeks. Can you give us a little bit more detail?
Yeah, absolutely. So the timeline to develop a beta version of the supply chain watchtower usually ranges from about 8 to 12 weeks, but that obviously depends on the complexity of the supply chain, the level of customization required, and then the different data sources available. In terms of sustainability, the solution is really designed to seamlessly integrate into existing technology stacks. So we often like to utilize Power BI and the broader Microsoft application suite. So it really is very seamless to develop out.
Yeah, I'm pretty sure that using familiar Microsoft application like Power BI kind of facilitate the user adoption, which is like a usual or typical challenge, especially when it comes to sustaining long-term adoption. Have you actually seen this kind of long-term adoption? Is it still in use today?
Yeah, so actually we're still working with this client on some other topics outside the supply chain. So we know more than a year since we implemented the tool's still being used on a daily basis and is really a cornerstone of their supply chain management now. And since it's been launched, there's been thousands and thousands of views. So it's been very successfully adopted and continues to be widely used today.
Okay. Well, thank you, James. So just to recap, the supply chain watchtower is really essential for establishing supplier transparency, focusing on the most pressing issues and anticipating challenges that may come forward before they actually become critical. It's a really powerful tool, in our view, to improve supplier performance and quality over time. Now, obviously, the other focus beyond delivery and quality is often affordability. And the watchtower is usually a great starting point because it helps to consolidate data from multiple ERP into one place. So we start to kind of see a broad picture of what we buy. And it allows to slice the spend in many ways by supplier, by category, by program, and so forth. And which is basically what we call a spend cube. But the spend cube is really helpful to answer multiple questions like, what product do we buy? How many suppliers do we have by category? How fragmented is our spend in a given category? And is there an opportunity to consolidate the supply base? However, to answer all those questions in a proper way, we have found that there's usually one major limitation, especially when building on data extracted from multiple ERP, and that's the data accuracy. So I'd like to actually turn to Rob to talk about this challenge. Rob, it seems pretty obvious that, to design sourcing strategies, we need first to understand what exactly we buy and have this picture with as much accuracy as we can. But from my experience, it's usually not the case. Can you explain us why this is and help us to, how do you help the supply chain teams kind of getting a better picture of what they buy?
Absolutely, Luc. Yeah, I think fixing, some of the data in our clients' ERP systems is essential because without some of that accurate data, informed decision-making really isn't that possible. And, perfect accuracy isn't required. Having data that's good enough is a solid foundation to build off of for initial improvements. But I think in the short term, one of the things that we found works really well is to use AI and machine learning to process some of that data to fix some of the immediate inaccuracies. But then when you're thinking longer term, there's some robust data governance that needs to be incorporated to really make sure that there's success. And then I think another component here is to really understand the spend through a taxonomy, and making sure that it's a well-defined taxonomy is crucial. Really allowing you to identify which parts belong in different business units and are actually the same kind of products in many cases. And typically we'd go down to, maybe level 3 or level 4 in a taxonomy, and that enables you to make some really precise sourcing decisions. So, for example, just distinguishing between passive and active electronics at the part level, rather than based solely on what the suppliers themselves are providing. And our experience with aerospace companies and their suppliers has sort of helped us to define and develop a common taxonomy structure that works really well across suppliers and parts.
Yeah, I mean, categorizing the parts in a best-in-class taxonomy sounds like a great idea, obviously, but it also sounds like a very long process. And for example, how do you achieve that when you're dealing with, I mean, commonly in this industry, we have clients with tens of thousands or even hundreds of thousands of parts.
Yeah, dealing with hundreds of thousands of parts can be daunting. We have a pretty systematic approach there. Usually we'd start with the spend, historical spend, look at the top 80%, covering maybe 10 to 20% of the part base. And then we're doing 100% accurate manual review of those parts. They're critical. For the remaining parts, something like 95% accuracy is usually sufficient. AI here is simply automating that categorization of the parts into a high quality taxonomy, and it really compresses our timelines down. So what used to take maybe 8 weeks or sometimes even longer, depending on the scale, can come down to even 2 to 3 weeks. And our AI models are fine-tuned for this particular purpose. They look at invoice data, they look at purchase order data, they're bringing in vendor descriptions, vendor names, part descriptions, and part names. They're looking at making that best prediction of what the category is at the line item level. And then, once we have that tool in place and we fine-tuned it for custom to our client, then in an ongoing sustainable process, when you add new parts, AI can kind of readily look at those new parts and quickly put them in the right categories. That reduces engineers' time. They don't like putting data into data entry fields. And I think it's maybe worth taking a look at an example just to see what this looks like.
Okay.
During this demo, we'll show examples of how tens of thousands of parts can be classified into a custom-built part taxonomy. And one of the key reasons we use AI is because it expedites this process from several weeks down to sometimes days. And AlixPartners starts with a proprietary taxonomy that has been built by working with numerous aerospace and defense leaders to build a best-in-class hierarchy that's designed specifically for supply markets, and it's optimized for strategic sourcing and also mitigating risks. Our taxonomy has 5 levels, and in the first level we have 11 high-level categories here, and then as we go down we get to about 70 categories, and then at level 4 and beyond we're above 200 levels. And we go down to those level 4 or 5s because we know, for example, that cable suppliers typically serviced certain types of cables like coax, fiber optic, radio frequency, or power cables, and they have particular supply bases for our clients, where a single supplier doesn't cover all of those different types. Now, that custom taxonomy is just a starting point. We know that businesses require customization, and so typically we would build a custom taxonomy using AI to fill in some of the areas that need more detail. So this is an example of a client of ours that required 3 different areas of specialization: electromechanical, electronic, and metals. And what we've really done here in this demo is just pull out maybe 10 invoices, random invoices, to show how AI can put hundreds of thousands of parts automatically into these categories. So this is a sample of the 10 parts that I've pulled today, and information in here includes things like the company's departments and divisions. It includes supplier categories, and then it includes text descriptions from the invoices themselves. So it could be from the purchase orders, from the company's web data sheets, all of those things would be pulled in, and then we may actually pull in external data from the web and scrape that to really supplement and have the most complete picture of the part that we can. And so we would then feed this into one of our tools, and let me just show you a basic example of a front-end system that we have to do this kind of thing. This is a very simplified example. When we actually do this in practice, we would run it in our back-end systems that can do this at scale. But basically, I'll upload a list of parts here. You can see it's the same parts as before. Relays, it could be computer software, Ethernet switches, network devices, headsets, battery chargers, antennas, etc. And then we'll upload a taxonomy here. So this is just a limited taxonomy. And this tool actually submits this to the large language model in real time. So when I press submit here, it's running through our secure systems in the back end and producing a list of categorized parts. And you can see it also does some vendor matching here, but we won't focus on that today. And so let me switch across to something that's been run through our backend systems. And just to give you an example of how the categorization works. And what we get back is really for, let's say this part here, a GPS antenna with L1, L2 bands and a TNC connector. We get back the top 3 categories in the taxonomy, and then we get a confidence score back as well. And we have a process in place to address the different ranges of confidence scores. And what that means is that we can go through and determine whether we need manual review, maybe just a minor manual review at, say, 95 to 100% confidence, or let's take a different part, for example, this RF antenna adapter. This one has the highest confidence is 90%, and therefore we would recommend that we do some manual review, especially if this part is one that has significant spend or critical operations. And so what that means is that we can really put things into the right categories across the board and come out with an initial taxonomy that has all parts assigned to it, and then we can iterate on that taxonomy and customize it further until it really matches with our client's operating model.
Well, it's great to see a real application of AI, I would say, and I know that's pretty impactful. Now, Rob, tell me, you're dealing with, you're talking about handling some of the most confidential data here of a company with AI. How do you ensure the confidentiality?
It's a great question. I think it's worth noting that there are a number of regulations like ITAR. There are a number of compliance IT standards like SOC 2 that need to be adhered to here. And typically, we would use our clients' on-premise servers to run most of this so that they can own it. And if necessary, we would put in place some walled-off private servers to manage this. And through many implementations, these have been very effective at maintaining all the security and regulatory standards.
Okay. All right. So, what you have presented is a great way to accelerate and build a well-structured and accurate span cube. And we think that's the right starting point for, developing some comprehensive sourcing strategies across different time horizons. In the short term, we have seen supply chain teams leveraging the span cube to look at the inflation by product category and launch rapid repricing efforts to claw back some inflation from the last 3 years. And in the mid to long term, we have seen supply chain teams develop category sourcing strategies, initiate some bidding processes to consolidate the spend across fewer, more strategic, less risky, more affordable suppliers. And I would say that here, being strategic is really a must, as we know that identifying alternative suppliers, alternative parts and components, and making design trade-offs. I mean, all of that takes significantly longer in aerospace and defense than in any other non-regulated industries. So we've talked about the span cube, and I would say that to drive all these strategies that I've mentioned right now, there's still usually one additional question that needs to be answered. And that's really, how much should we buy for a given part? So to dive deeper into this question, I'd like to invite Venki to talk about should-cost modeling. Venki, thank you for joining. Can you start by explaining what exactly is should-cost modeling and why is it so valuable?
Hello, everyone. Thank you for having me here, Luc. Sure. So should-cost modeling has become an essential tool in product development and procurement processes across most industries. In procurement particularly, it helps us assess the gap between the actual price paid as part of our purchase orders and the theoretical best possible price. Conventionally, should-cost models have been built bottoms up. So, breaking down a given product into its elementary parts, and then having a specialist, usually an engineer, look at the quantity and the grade of raw materials, look at the types of machine used, how many human hours required, and of course, add that up with some of the overheads like engineering, R&D, transportation costs, etc. So typically, this process also requires benchmarking data from similar parts to serve as baseline and validate our assumptions. Now, as this sounds, in procurement, should-cost models provide a solid foundation for fact-based negotiations with our vendor partners.
Yeah, I agree. I mean, I've seen should-cost being very useful in calibrating negotiation objectives and really start anchoring discussions around a target that is backed by should-cost analysis. Now, to address, how do you address the traditional challenge of should-cost modeling being very time-consuming, resource-intensive? Sometimes it takes a few weeks to actually turn around a model, and especially in our industry when we are dealing with complex high-mix portfolios.
Great question, Luc. And in fact, this is what has been grappling most of our clients as well. So the traditional approach, as I outlined, is very detailed and can achieve 90 to 95% accuracy, but it is quite time-consuming and needs subject matter expertise. In a high-volume, low-mix industry like, say, automotive, this effort is worth it. But in a low-volume and high-mix industry like aerospace and defense, leveraging automation via AI and parametrization to streamline the process is often the best approach. And by creating these cost models via parametrization, we can generate cost data for any part variant based on just a few inputs. These models, the parametric and AI-generated models, do maintain the bottoms-up approach and do provide us relatively high accuracy of, let's say, about 70 to 75%. But they greatly accelerate the cost estimation process, cutting the effort usually from days to a few hours, and therefore enable should-cost modeling for a large number of parts.
I mean, that sounds very compelling. Can you show us how it works in practice?
Let's talk about the Global Trade Optimizer, or the GTO. Now, the GTO is an end-to-end supply chain optimization platform. In its foundation are 6 key modules which help address the entire supply chain landscape. One such module, which we will learn more about today, is the should-costing module. For today's demo, let's take the example of these aluminum rotors, which are usually parts of brake systems that one would find on a light armored vehicle, something commonly used in many aerospace systems. Now, up front, let me show you how GTO can be used to build should-cost models for these rotors in a bottoms-up traditional fashion. Now, what you see here is the landing page of GTO. Let's go into the platform, and what you see here is the platform helps you calculate and identify cost drivers such as raw materials, different types of processing, fixed costs, capital expenditure, engineering and design, overhead, margin, and so on and so forth. Let's look at raw materials first. Now, within raw materials, a user can pick the commodity of choice from over 14,000 live commodities that are hosted in the platform. In this particular case, we have used aerospace grade aluminum 7075. The index tells us what the current cost is in US dollar per metric ton. In this case, you can see that this is $3830.18. Now, along with this, build in the weight, dimensions, and cavity of the particular part. And what you can calculate is what is the raw material cost per unit of rotor. In this case, it comes out to a little over $10. Similarly, we can look at processing costs, and let me show you how processing for machining works in this platform. Now, even within processing, there are three different factors. There's labor, there's overall machining cost, and then there's utility. For labor as well as machining cost, we leverage GTO databases to pull in the relevant information. Now, as you can see here, for the machining cost, the platform takes into account all assumptions such as how many hours per day will the machines be used, how many days of the week, what is the cost of this machine, and again, we pick this machine from a wide variety of database and repository of machines that we have in GTO. In this particular case, cost of the machine is $600,000, and the platform does the math to tell us what is the per unit rotor cost for this particular machine. Then we can look at some of the other miscellaneous expenses such as overhead, margin, logistics, duty, tariff, etc. Particularly for logistics and duty and tariff, again, GTO has a database that you can use and pick out these costs based on where our raw materials are coming from, are we incurring any duty or tariff, and so on and so forth. And finally, what you get is a should cost model that identifies and splits out costs across various cost drivers. As you can see here, we have costs across raw material, labor, processing, and processing split into casting and machining, engineering and design, overhead, margin, and so on and so forth. Now, it is important to remember that while a bottoms-up should cost like this has high accuracy, it involves time commitment and subject matter expertise. And increasingly, what we've seen is our clients have asked us for something that's quick and scalable, even if that means that they would need to dial down on accuracy a little bit. And this is what gave birth to the AI-based GTO should costing. Let me dive into this right away. Now, as you can see here, we give the GTO AI prompt for brake assembly rotor and the country of manufacturing. And the engine immediately responds with percentage cost split between key drivers and empowers the user to modify based on their knowledge and subject matter expertise. For example, in this particular case, I know that my rotor is purely made of aluminum. So I can remove all the other recommendations and tell the model that, hey, 100% of my raw material cost comes from aluminum. I can then pick one of the aluminum indices that is relevant for my particular product. The tool also shows how the particular commodity pricing has changed in the 3, 6, 12, and 24-month period, and we can attach the content. Similarly, labor cost. You can go in here, pick the labor cost based on geography from across our repository, and plug it into the model. Last but not the least, I will select the indices for a few other commodities, and that's it. We need to save this by a particular name. And we have the should cost model, an AI-based should cost model for an aluminum rotor ready right here. Now, again, this is directional and in percentages, but with some straightforward math based on how much of raw material is used and so on and so forth, you can calculate the dollar values as well. Now, these models, I would say, are 70% accurate compared to our bottoms-up should cost model. But hey, we built this should cost model in literally less than 2 minutes. And what that means is that these should cost models can be scaled across hundreds and thousands of parts in literally no time. In fact, over the past 12 months, we have helped clients negotiate with their vendors by leveraging a data-driven approach. Even with 70% accuracy, our clients were able to negotiate aggressively and drive savings across numerous categories within a matter of few weeks, all with the help of GTO's AI should costing capabilities. Well, I'll stop here in interest of time, but if anyone's interested in learning more about should cost modeling or how we do it at AlixPartners using GTO, I'd encourage them to reach out to us. Thank you so much.
Thanks, Venki. I think this is very impressive, and that's another great real application of AI. And I can see how this tool can help to quickly identify cost gaps and focus efforts on supplier and parts where with the highest savings potential. So as we are wrapping up for today's session before moving to the Q&A, I'd like to highlight a few critical points. We all know that supply chain management is paramount concern across the aerospace and defense industry. For the first time, the supply chain rather than customer demand is really dictating how much we can produce. Most of the CEO in this industry have publicly stated that supply chain is very high in terms of concern and directly impact their company's sales and margin. And according to Aviation Week, supply chain disruption will cost the industry more than $200 billion between 2022 and 2025. So in this challenging context, successful companies, in our view, are the ones that really excel in anticipating supply chain issues. Can they manage them before they become really critical? And also the ones that drive strategic actions to de-risk their supply chain over time. We have seen leading aerospace and defense organization setting also clear cost reduction targets to drive affordability, to enable to win new contracts. And those targets are usually set at program level to create a pool for action from a multifunctional team where everyone is accountable and rewarded to achieve a common goal. And this cross-functional collaboration really ensure that every aspect from engineering to procurement to production is covered, making those companies in general more effective and more resilient. So, however, I think that achieving success requires the key enablers that we have been discussing today. These tools are really essential to shift into a proactive strategic supply chain management, which have a significant impact on meeting deliveries, but also estimated cost at completion. Now, I would like to open the floor to questions. So I can see there's already some question in the chat. We can get started with those, but feel free to keep adding questions that you may have. And of course, if we don't have time to go through all the questions by the end of the webinar, we'll make sure to follow up afterwards. So let me see. That could be a question for you, Rob. So the AI-based approach for part classification looks highly effective for part classification, but it also sounds like it's a one-time effort. How do you ensure the spend cube remains up to date, particularly in aerospace and defense, where there is a high churn, like 20-40% annually on certain program? especially during the design and development phases, where there is a high turnover, I guess, of parts, and when frequent modification and upgrade are common. Rob, can you answer one?
That's a great question. I think one of my clients asked this of us recently. You've built this spend cube. How do we maintain it, essentially? And new parts are coming in every day. They're different. And I think one of the ways that we addressed this was that in creating the spend cube the first time, we really put a lot of effort into fine-tuning those large language models, because they sit in a secure environment in our client systems, and we've spent the effort to actually deploy them there. It meant that they can take that large language model and use it every day. So as new parts come in, and this actually happens in real time for them now this year, they're able to have new parts come in, have them classified, have confidence scores applied, and then as I mentioned, there's that process for forking off and figuring out whether it's accurate enough. If it is, great, and if it's not accurate enough, there's a review process for the data governance and engineering teams.
Okay. Let's see. Next question. James, that may be for you, because that's about the watchtower. So considering the need of refinance in a higher interest rate environment and the impact of the Boeing strike on the supply chain, can you elaborate on how you assess and monitor financial risk with the watchtower?
Yeah, of course, and it's a very good question. So typically we like to approach the assessment across two time horizons. So in the short term, liquidity and solvency is obviously key. So our scoring system really drills down on the balance sheet health of the supplier and looks at the risk of default over that next 12-month horizon. So that entails looking at things such as the current cash position, looking if there's any upcoming debt maturities, and really will assess the impact of any of those interest rate rises on some of those refinancing activities. And this is really key because obviously when the liquidity gets tight, this is when you start to see some challenges around quality, part shortages, and even capacity. For the longer term assessment, we tend to move away from the balance sheet and try to answer the question, is the supplier viable in the long term? So to do this, we look at things such as product segments that they're in, we look at the profitability trends of the supplier, and then we also look at how reliant they are on us as a customer to really build out that holistic view on the financial outlook.
Do you feel like this is a risk that is usually under surveillance and under control, or not that much?
I think a lot of time there's probably limited visibility into the financials. I think there's usually at sourcing some initial investigation in terms of what's the financial health, but over time, I think that monitoring process is less and less focused on those suppliers. So you can be surprised by some certain situations where the financials deteriorate over time.
Okay. Next question is about should cost. I can probably take this one. It's actually, so what's a typical successful outcome for a negotiation based on should cost, and how to prioritize? I've seen recently negotiation for memory components, for example, where, we did should cost analysis. It was indicating that 65% of the cost was driven by raw material. And what we did is really showing some evidence of commodity deflation in material like silicon, aluminum, and based on that, we anchored the conversation on a fact-based analysis, and we went into the negotiation with a request to reduce the price by 20% based on this evidence. And obviously we didn't get the 20%, but we were able to secure a good savings, I think between 10 to 15%. And that's not very unlikely for, parts that are heavily driven by material costs, and for which we have seen deflation. So I mentioned aluminum, but there are other type of raw material in our industry that really spiked in 2022 2023, and since that time landed to something that is more acceptable in terms of price, I would say. I mean, it's always a good time to go back to the supplier with this type of should cost analysis and start to claim for some inflation clawback. There's a question for you, probably Venki here. What data sources does your tool, so I guess the GTO, utilize to generate AI-driven should cost estimates?
Yeah, good question. So GTO, the AI version of GTO runs its own engine to give us the should cost model estimates. Now, additionally, we leverage commodity indices of the underlying raw materials being used. We also have a repository of labor, utility, logistics, market rates that we update very frequently that help us get the accurate cost models as possible. In terms of the prompt to the AI model, the more the detail, the better. So for a more accurate should cost, if we can put in characteristics of a particular part or the grade of aluminum and so on and so forth, we will get a more accurate should cost model. But if speed is of priority and we have limited information, that's fine. And like you said, we can get a directional should cost model and have that data to bring our vendor partners to the table and then negotiate with them purely based on facts and how raw material prices and other factors have moved over a period of time.
Yeah. Okay. There's another question that may be for you here. So given the significant inflationary pressures over the past few years, maybe that relates to what I was just describing, but can should cost modeling be used for tracking cost efficiency?
Yeah, absolutely. And all should cost models within GTO are linked to underlying market indices. And just as I mentioned, be it raw material, labor rates, logistics, etc., which makes these models dynamic. So if you build a model today, it is relevant and accurate from a year from now, and the model would have adjusted for itself based on key market fluctuations. And that is one of the advantages of GTO. It helps clients as well as AlixPartners consultants proactively track price increases or reductions and take actions accordingly.
Okay. Question about the spend cube. So Rob, probably for you. You mentioned being able to supplement the data extracted from purchase orders with external data to improve spend categorization. Can you elaborate on the process and the type of sources that you use and what you have observed specifically for non-commodity parts specifically designed for aerospace and defense programs?
Okay. Yeah. I think maybe I'll just go back to the commodity parts for a second. I think a lot of the time there are catalogs that we would obviously acquire and pull in. Often our clients have that data, but we may just go and acquire it ourselves, depending on what data quality there is in the records. And obviously we can process those sheets, extract the data out automatically with some AI tools and some other tools that we have. The non-commodity side is more of a challenge because some of that information is sensitive. It may come down to asking for basic spec sheets or drawings if they are available. And then I think we would bump that up against the priority for the company and the speed with which we're looking to go at. And I think that will come down to the business's appetite for how soon we can see the benefits.
Okay. Yeah, makes sense. I see we're almost at time. I'm going to take two more questions. So one is on the watchtower here. Are you also monitoring cyber risk? James, can you answer this one?
Yeah, and it's a good question, and one that's certainly becoming more relevant over time, particularly in the defense segment. The short answer is yes. So that's one of the key modules that we offer, and we're able to leverage a range of internal but also external data sources, which allow us to assess the cyber risk across our supply chain.
Yeah. Well, last question is also for you, James. How do you factor sudden events like how do you factor sudden events impacting the supply base, like the war in Ukraine, for example?
Yeah, so we approach this through two different avenues. So the first is you might recall on the Watchtower there was a scoring category called triggers, and essentially what this is it's a way that anyone in your organization could submit a trigger to a particular supplier. So if they were having a conversation with the CFO and they were asking for some price increases, or if one of the buyers had heard about some raw material shortages, they can log on to the tool and they can submit a trigger, and that gets captured within the overall risk score for that particular supplier. So obviously that's a really nice way to capture some of those risks where there's no underlying data that would drive that. The second way that we aim to capture this is we do web scraping. So we look at where the different suppliers are based. We like to map out the footprint, and then we can monitor using AI as well some of those more generic risks that might be associated with that particular supplier.
Okay.
Great. Thank you all for attending today's webinar. We hope you found the insights and strategies we've shared valuable and applicable to your own supply chain challenges. If you have any further questions or would like to dive deeper into any of the topics discussed, please feel free to reach out to us directly. We're always happy to continue the conversation. Thanks again for your time, participation, and thoughtful questions. We look forward to seeing you at our next event. Have a great day.